Okay, in this video, I'm going to show you how to do a few calculations that will assist you in completing various assignments throughout the courses. So I'm just using a generic table of crime data. Depending on what course you're in, the assignment might look identical or it might look a little different, but either way, you're going to use one of these calculations to figure out the answers to whatever questions you're supposed to submit. So I'm just going to go through each of these calculations once or a couple of times just to give you an idea of how to do it. And then you need to practice on your own before you take your quiz. Go through and make sure you understand the calculations and how they work and what the numbers should look like, things like that. So the first one we're going to start with is what's called a percent of total. I don't know of any assignment that uses the clearance rate, but that's an example of a percent of total. A clearance rate is the number of crimes that have led to an arrest or been cleared by arrest. So that is a percentage of the total number of crimes. So here we can look at this formula. Probably the formula you're most familiar with. It is when you take a part, you divide it by the whole number, and then you multiply by 100 to put it into a percentage form that you're familiar with. So if we look at one here, if we wanted to know what percentage of violent crimes are murder or non-negligent manslaughter, we would start with the part, which is the murder and manslaughter, 15,586. We would divide it by the number of violent crimes, which is 1,425,486, and then we multiply that by 100, and we would get 1.09%. So we would word that murder and manslaughter make up 1.09% of violent crime in the United States in the year 2000. If we were looking at populations like correctional populations, what population of the total correctional population is in prison, we would take the prison number, divide it by the total number, multiply it by 100, we would get a percentage. So that's percent of total. On assignments that use crime rates, and you might also see arrest rates. This is the same formula. It's just about whichever number you're using. So in this particular case, we have a lot of crimes. We want to figure out how this number compares to this number when these populations aren't even, when they're not the same. So that's what we use a crime rate for. And you're going to see it's multiplied by 100,000. And that's an easy way to compare things that are unsimilar or insimilar. I don't know, one of those. So if you wanted to compare the homicide rate in Cleburne compared to Dallas, or Chicago compared to Nashville, New York City compared to New Orleans, when those populations don't equal each other, we can't rely on the hard numbers. So we put it into a crime rate, and we normally look at 100,000 people because that's a workable percentage or a workable number that that is easy for our brains to understand. So look at the formula: crimes divided by population times 100,000. So let's just use, we'll stick with that same number. The crime rate for homicide in 2000 was, and we'll put the part, or the crimes, number of crimes, 15,586, divided by the total, the population for that area. The United States in 2001 was, or 2000 was 281,421,906, and then we multiply that by 100,000, and we can see that we have a rate of 5.54%, or excuse me, it's not a percentage, 5.54 murders per 100,000 people in the United States in 2000. And we can check that. I have put these all in white font, but if I could change this really quickly, make that black, 5.5. So this rounds up or rounds to the nearest decimal number. singular decimal number, 5.5 murders per 100,000 people. So this data on this table doesn't include arrest, but if this was, for example, the number of arrests for burglary, then instead of it being a crime rate, it would be an arrest rate. So the formulas are the same. I want you to notice on the first two formulas, when you go back to grade school and you think about learning the order of operations, parentheses, exponents, multiply, divide, add, subtract, left to right. This doesn't create any problems because we're on the same level, multiplying and dividing. If I multiply, let's say, for example, if I got out of order here and I did the calculation incorrectly, 15,586, and I multiplied that by 100,000, and then I got around to dividing by the total population, 281,421,906, I get the same answer. It's not different. Order of operations doesn't really affect the way this calculation is done because the rules dictate that we multiply and divide basically in whichever order comes first. And so this turns out to be the same answer. On the last one, though, when we talk about percent change, you have to follow the order of operations. It requires that you do this first part first before you divide and multiply. So what we're looking at with percent change is the comparison of one number to a previous year. So if I want to look at how at what percentage did the population grow from 2009 to 2000, or from 2008 to 2009? I want to know what the percentage change is, not just what the total number change is, but what percentage change. So when we do this formula, we're going to start with the new number, which is our current year, whatever year we're starting with here. And we're going to do 307,006,550. And we're going to subtract from that number the old number, which let's just look, we want to know from 2000 how it changed. So let's go to that 281,421,906. You notice I'm closing parentheses so that order of operations works. It's going to do that subtraction problem first. And then I'm going to divide by the old number, 281,421,906. And then I can multiply by 100, and I'm going to get a percent change, 9.09%. So we could say that the population increased from in 2009 compared to 2000, the population increased 9.09%. And if I did the order of operations incorrectly, if I just did the numbers without regard for our parentheses, you'll see that I get a wild number that doesn't look right, and that won't be an answer choice. So if you see something like that, then you didn't put those parentheses in. So make sure you follow the order of operations. Now, an easy trick on this one is to look at the years that you compared, whatever the numbers were, and look just without, I'm not going to add and subtract, but I can use my eyes and I can see that 2009, the population is bigger than the population in 2000. So I know that my number should be a positive percent change. So that's something that we can look at, and let's do the calculation incorrectly again, but let's use order of operations correctly. But let's say instead we make a mistake and we do the old population first instead of the new population. We do old minus new, and we divide that by that old number, and then multiply by 1,000. We get the same answer. It's just a negative number. Okay. So what we know is if we did this, we got a negative number, we go back and check and we see that this number is in fact bigger than that number, then we know we did it wrong or incorrectly, because our number should be positive growth, not negative growth. Now, so if you, common sense tells us if the answer is the same, and I go back and check and say, okay, that's bigger than that, it can't be a negative decrease. I can just take that minus off and just live with it and know that I did the percentage correctly, but I got the wrong sign. So I'll just change the sign and that should be the correct answer. So the last thing I want to mention is really just kind of a warning. Make sure that when you're going through your quiz that you're reading the question carefully and understanding what it is that you're solving for and not missing something. So one thing that I'll note up here is, for example, on percent change, you will be asked a question without giving the data to find the percent change of crime rates from year to year. So let's say, for example, I want to know the percent change from the crime rates from robbery from 2006 compared to 2005. So one thing you'll notice is that that data is missing currently. You haven't figured out the crime rate. So let's say that you're not paying attention and you just decide to figure out percent change of the hard number. And so we can do that really easily. Let's do new minus old. So the new rate 2006 is 449,246. Subtract from that the old number, 417,438. Close parentheses. Divided by that old number, 417,438 times 100. And I get a relatively logical looking number, 7.62%. You can see 2006 number is in fact bigger. So we know we did it correctly because our percentage change is positive and the number grew. So that should be right. But that's not what the question was asking. It wasn't asking the percent change of the number of robberies. It was asking the percent change of the rate of robbery. So we need to figure that part out first. So this is really a 3 calculation step. I have to do a calculation for the 2006 number to find the crime rate, and then the number to find the crime rate for 2005. And then I can use those 2 numbers to calculate percent change. So let's do that really quickly. What was our formula for crime rate? It was, and I'm just going to write here. I'm trying to find in this box, I want 2005, and this one I'll do 2006, and this one I'll do percent change. So 2005, my number, I'm going to put equals, my number of crimes for robbery was 417,438. I need to divide that by the population for 2005, which was 296,507,061. And then I'm going to multiply that by 100,000. And I get a rate of 141.79 or 140.8 robberies per 100,000 people. Let's go to 2006, do the same thing. We know 449,246 crimes, robberies, compared to divided by 299,398,484 in the population. Multiply that by 100,000, and we get a crime rate of that looks wrong. Let me make sure I put my numbers in correctly. Did I think I did too many zeros. I think I did it by 1,000,000 instead of 100,000. If it changes, no, that didn't change. Okay, let me start over because that could be right, but it doesn't look right. So let me do that again. So we're doing percent change or crime rate, number of crimes, 449,246. Maybe that number was wrong. And we're going to divide that by the population, which was 299,398,484, and to multiply that by 100,000. Okay, so I had put in too many people or too many crimes, something. I don't know what I did, but that looks more logical. 150.05 robberies per 100,000 people in the United States in 2006. So now I've got those two. Now I can do my percent change using these 2 data points that we need. And we know we're going to open parentheses. We're going to use our new number, which is 2006. Let's just round to 2 decimal points, 05. We're going to subtract 140.8 140.79 rounding divided by 140.79 times 100, and that should give me a percent change of 6.58 positive. So we know the crime number went up. Okay, that we know that the crime rate went up. So the crime rate is higher in the new year than it was in the old year. So our percent change is positive. It went up. So that's what we're going to use. Now, I can confirm these. Did I get these right? 140.8, 150. Pretty simple. All right, so what I'm going to do right now is I'm going to pause the video, or I'm not going to pause the video. Let me rephrase that. You're going to pause the video if you want to. What I can do is I can show you some of these percent changes. So let me do this. I don't know what this is going to be like in a video. This might ruin everything. I'm not really sure, but I'm going to try to, I don't know if what you're able to see really easily. So I'm just going to highlight the violent crime rate category, and I will show you what the violent crime rate rates are for each of these years. So what I recommend doing is practicing these formulas a couple of times. Just do them a couple of times and make sure you're comfortable with them before you sit down and take your quiz. So if you want to pause the video really quickly, and then obviously I'll show you the rates, and you can check your work. So pause. I'm assuming you paused. I'm going to show you the answers. So these are the violent crime rates for each year. So if you did these calculations, a handful of them, a couple of them, and you got it, and you got every one of them, then you've got it figured out. Practice percent change a couple of times. I'll scroll back up so you can check your work, pause the video if necessary. Practice percent change, practice crime rate, the percent of whole. And then when you take your quiz, you should be prepared for that. And you should do well. As always, reach out if you have any questions. If you're uncomfortable before you sit down and take this quiz, reach out to me if you need additional materials or additional practice, or if there's something that you just don't understand. I am available. Reach out. Don't just throw this out there and say, I'm not going to do it because I'm uncomfortable with it. Reach out. I will help you get comfortable with these calculations or the ideas behind them.